This problem is about classifying quadratic expressions with respect to factoring. Suppose we complete the square, and what we get is something like x plus 6 squared. That is factored as x plus 6 times x plus 6. What if the last line is something like x plus 6 squared minus 4? If that is the case, we can factor via the difference of squares theorem. This is x plus 6 squared minus 2 squared. So in the difference of squares theorem, a will be played by x plus 6 and b will be played by 2. And then a squared minus b squared is x plus 6 squared minus 2 squared. So this one will cleanly factor as x plus 6 plus 2, x plus 6 minus 2. And that's x plus 8 times x plus 4. So this can be factored into two different linear factors. So that was the second case. What if the last line is something like x plus 6 squared plus 25? Now that is similar to the previous one. 4 is a square, we have a complete square. 25 is a square, we have a complete square. But it's crucial that there is a plus sign between them. The sum of squares can never be factored. This one cannot be factored over integers and cannot be factored over the real numbers. So what's left is the tricky one. When we see something like x plus 6 squared minus 3. And this is the case where integer and real will behave differently. This one cannot be factored over the integers, but over the reals is another story, because 3 is a square, not over the integers, but over the real numbers. There is a number that squares to 3, and it's called square root of 3. So then 3 can be rewritten as the square of its own square root, which is kind of silly, but then we can proceed with the difference of squares theorem. Now 6 plus root 3 and 6 minus root 3 are real numbers but not integers. So this is the strangest character because it cannot be factored over the integers, but it can be factored over the real numbers. In summary, I'm going to use different examples. After completing the square, you have just a complete square. That means it's already factored. It is a complete square. If you have a number added, any number, square or not, this one cannot be factored because the sum of two squares cannot be factored. If a positive number is subtracted from the complete square, the expression will factor over the reals. And if that number subtracted is a perfect square, then it will factor over the integer. Otherwise, it will just factor over the real numbers. Because we're going to be able to factor this via the difference of squares theorem using the fact that 10 is the square of its own square root. But that's not an integer at all. Thank you for watching.